What's going on, everybody? I'm Willie. What's going on, everybody? I'm Will, the Orgo tutor, and here we are back with another video. So in this video, we're going to be learning what's going on, everybody. I'm Will, the Orgo tutor. Welcome back to my channel. So in this video, we're going to be going over how to classify primary, secondary, and tertiary for either alkyl halides, for alcohols, for amines or amides, or even for carbocations. So without further ado, let's just get right into it. Now, when it comes to organic chemistry, I love approaching things by giving a set of rules, because if you can apply a set of rules, all you have to do is follow those rules and you'll be able to answer a million practice problems very, very easily. So we can start off with rules for classifying primary, secondary, and tertiary. Now, if we start over here with alkyl halides, rule number one, if let's say we're given a problem like this and we are asked to classify the alkyl halide, right? Rule number one, all you need to do is find your halogen. So X would be our halogen here, right? Like F, Cl, Br, or I, these are all the elements that you can find in group 17. Now, first step is you want to find your halogen, right? So in this case right here, we established that it's right there as listed by number one. Step two is you're going to find the carbon that X is attached to, that your halogen is attached to. And we're going to call this carbon the C, the orange C, right? So that Br over here is attached to this carbon. Now, rule number three, all you need to do is count how many carbons are directly attached to this carbon over here. So when we do this, we try to go ahead and count how many carbons we have. And now directly connected to this carbon is one on this side and two on that side. So because we have two carbons connected here, that means we have a secondary alkyl halide. Now, if we want to be a little bit more specific, we know that this right here is a bromine. So this would be bromide, secondary alkyl bromide. And that would be the most specific way to answer this, all right? Or, of course, you can give a name. But again, giving a name for this won't actually give it a classification for primary, secondary, tertiary. Now, it is that simple. And the thing I like about the rules that I created is that you apply these rules to literally every other thing. And it doesn't just apply to alkyl halides, for alcohols, amines, amides, carbocations. It's all basically around the same idea. So if we look at alcohols, it's the same thing. Instead of finding your halogen, this time you're going to find your OH, your alcohol. And so if we look at this example right here, we have our alcohol right there. Now the next step is going to find the carbon that OH is attached to, which is right here, right? The carbon in orange. And you're going to count how many carbons are attached to that C. So this C right here, we're going to count how many carbons are attached to it. That's one. So this would be a primary alcohol. All right. Now, what if we were talking about carbocations? So it's a little bit easier now, because here all you need is two steps. You're going to find the carbon with the plus charge, and we're going to call this our CC plus, or carbocation, right? And the second step is to count how many carbons are directly attached to the carbocation. So step one would be over here, just like I noted. That's your carbocation. And all you need to do is count how many carbons are attached to that orange carbon. And what we do is we see 1, 2, 3. So this is three carbons is a tertiary carbocation. That's it. And now for amines or amides, again, you find your N, because remember the M for amines, amides, that M means nitrogen, right? And so the first step we're going to do is we're going to find our N. So let's say we wanted to find our N over here. And the second step is you're going to count how many carbons are directly attached to N. So 1 and 2, right? Keep in mind, this carbon does not count as directly attached, right? Because we don't see a line connecting this N to that carbon. So because it doesn't exist, we do not count the CH3 on the very left. So 1 and 2. So we have 2 here. This is going to be a secondary amide. Now this is an amide. Again, if we remember why, amide, remember the ID sounds like carboxylic acid. And we know that in a carboxylic acid, we have this C double bond O backbone. So whenever you have an N connected to C double bond O, that's an amide. So this right here is a secondary amide. All right. Now, what if we were talking about this example over here? So again, we look back at our rules. Rule number one is find your N. And rule number 2 is count how many carbons are directly attached to that end. And so we have 1 carbon here directly attached to the end. So 1 carbon is going to give us a primary amine. Now in this case, this is not an amide, it's an amine. Why? Because we don't see a C double bond O here. So if there was a C double bond O there, that would make it an amide. But since we don't have it, this is an amine. All right. Now let's go over a couple of practice problems just to make sure that we got this down 100%. All right. So we need to classify the following as primary, secondary, or tertiary. So this right here is, number 1, is an alkyl halide, right? How did we know that? Well, because we see our halogen, so we need to classify the alkyl halide. Now, specifically, this is an alkyl iodide, because we have an iodine, right? And all we need to do, remember the rules, find your halogen, find the carbon that the halogen's attached to, and count how many carbons are attached to this carbon. So that would be 1, 2, 3 directly attached. Keep in mind, this one does not count. We do not have a line connecting those directly. So 3 carbons, this is going to be a tertiary alkyl halide. Or if we want to be more specific, a tertiary alkyl iodide. All right. Now, let's look at the second one. Here, another alkyl halide, because we have a Br, so this is a halogen, right? So this is going to be an alkyl bromide. Now again, find the halogen. You find the carbon that the halogen's attached to, and now you count how many carbons are attached to this carbon. Remember, that's not including this carbon. Do we see any carbons attached here? No, we don't, right? So in this case, instead of calling this a primary, like some people would think, this has 0 carbons connected to it. So what do we call it when there's 0 carbons connected? We're going to call this a methyl alkyl bromide. Now, if you want to make the name a little shorter, you can just call this methyl bromide. All right? So, now, this is a little bit different from what we saw before. We were only talking about primary, secondary, and tertiary, and now we realize there's actually something below primary. There is a methyl. So the 0 degree, so if we look here, it says classify the following as primary, secondary, tertiary. If we had a 0 degree, this would be a methyl. All right. Now, let's go ahead and look at the next one. So here we see an OH right there, so that's going to be an alcohol. So now we know that this is an alcohol. Now the question is what kind? We find our alcohol, find the carbon that the alcohol is attached to, and we count how many carbons are directly attached to this carbon. And we see over here just 1. So this is going to be a primary alcohol. All right. Now, that's it. We covered 3 practice problems. Let's go over the next 3. We see this has a plus charge on a carbon, so this is going to be a carbocation. And remember, this is even easier. We find our carbon with the plus charge, which is right there, and we count how many carbons are directly attached. And so we have 1 on this side, 2. So this is going to be a secondary carbocation. All right. Now, let's look at this structure over here. Now, this is a little bit interesting because we actually have to draw this one out. So let's draw it out. CH3. C, we have a double bond going up O. Keep going, we have an N. And this N has 2 CH3s connected to it. So let's draw those in. 1 over here and 1 over here. So this is an amide, right? Because we have the C double bond O backbone, so it's going to be an amide. And now all we need to do is find our N and count how many carbons are attached to that N directly. So 1, 2, and 3. So this, because we have 3 carbons directly attached to N, this is going to be a tertiary amide. And last but not least, let's look over here. So here we have our N, and this time I don't see a C double bond O backbone, so this is going to be an amine. And so all I need to do is count how many carbons are attached to my N directly. So this is 1, 2, 3, and 4. So because this is 4, instead of calling this a quaternary amine, this N is supposed to have a plus charge on it. And the reason why is because it has a formal charge of +1 if you were to do the formal charge calculation, which I'll cover in a separate video. And you realize that instead of calling this an amine, this is going to be called a quaternary ammonium ion. And that's the proper name for it. Now, why do we call it an ammonium ion instead of an amine? Well, because the difference is whenever you have an amine, usually your N does not have a charge. But once you give N a charge, right, like a plus charge, for example, it becomes an ion. And so we call this an ammonium ion. All right? So that's going to be it for today's video. I hope this helped out. I'm Will, the Orgo tutor, and I'll see you guys in the next one.